So let's go through some questions that could potentially be on your test. This doesn't mean that it's limited to these questions, but this should be a nice review. So the first question asks us to write a formula for the nth term. That just means we want to write a general formula that we can use to find any term in this sequence here. The first thing we need to do is identify what type of sequence this is. And hopefully you realize or you notice that this is a geometric sequence. So there's a number that we can multiply every time, a common ratio, that will go from 2160, 720, 240, 80, etc. So first let's maybe figure out what that common ratio is. So in order to figure out a common ratio, we take a term and we divide by the one previously before it. So 720 divided by the term previously before it is 2160. So we can go ahead and use our calculator and figure out what fraction that is. 720 divided by 2160. And that is 1/3. So our common ratio is 1/3. Okay, so let's write down our geometric sequence formula. A sub n equals first term times the common ratio raised to the n minus 1. So when we write a general formula, we're going to leave n blank. We'll just leave it as n. So a sub n equals, our first term is 2160 times our common ratio, and that common ratio is raised to the n minus 1. And we leave this as is. So this would be our general formula to write any term in the sequence. So if we wanted to know the 80th term, we'd substitute 80 in for n. All right, let's look at this next one. So it's a similar type question. It's asking us again for the formula for the nth term of the sequence B shown below. So once again, we want to figure out what type of sequence this is. And if you take a look at it, okay, it's looking like an arithmetic sequence. So arithmetic sequence would be a sub n equals a sub 1 plus the common difference times n minus 1. So looking at this, our first term is 15, and our common difference. Okay, if you don't realize it right away, you could always take a term and subtract from the one previously before it. So 23 minus 15 would be 8. So our common difference is 8 times n minus 1. So if this was a multiple choice question, it would probably be distributed out. And then simplified further to be 7 plus 8n, or 8n plus 7. So this would be the general formula, the general explicit form to write any term in the sequence. So in this question, they give us the fourth term is 8, the 11th term is 36, and once again, we want to determine a formula. And they also tell us that it's an arithmetic sequence, which is good to know because we would be using this formula here. So the difference with this question is that they don't give us a sequence listed out. We don't have the first term. We don't have the common difference, so we can't just pull things very easily. So instead, that's where we could subtract the 11th term, which is 36, minus the fourth term, which is 8, and then divide by term number 11 minus term number 4. So this is that little shortcut that we did in class. So we get 28 divided by 7, which is 4. So our common difference is 4. But we also need our first term. So if you want, you could always backtrack from the fourth term, or we can use our formula if we want. We could just say, okay, they give us, we can just make n 4, and we could make a sub 4 8, and we could substitute that into our formula. So I'll say, okay, I'm going to make a sub n 8, And I'm going to solve for the first term. The common difference I found was 4, and I'm going to use 4 as the term number. And after doing this, we get -4 as our first term. Or another way, which I was mentioning before with backtracking, if we know that the fourth term is 8 and we know our common difference is 4, well then the third term has to be 4, the second term has to be 0, and the first term has to be -4. So now we have the two things we need in order to write that general form. We have the first term and we have the common difference. So our final answer is going to be a sub n equals the first term, which is -4, plus 4 times n minus 1. And once again, we could distribute this out just to simplify it. And we get a sub n equals 4n minus 8. That would be our general form to find any term number. Okay, question 4 asks for the common difference. So if you don't realize what it's going up by, so you might realize, okay, from 5x to 3x, and when it says common difference, you know you're dealing with an arithmetic sequence. So from 5x to 3x, it looks like we're subtracting 2x. From 8 to 10, it looks like we're adding 2. We could check that. Let's look from here to here. Again, we're subtracting 2x, and again, we're adding 2. But if you don't realize that just by looking at it, you can do where you take one term, so 3x plus 10, and subtract the previous term before it. Just don't forget to distribute that negative sign. Okay, and when we do that, we get -2x plus 2. So same answer, just a different way to do it. Question 5 asks for the common ratio. So when we're dealing with a common ratio, that's a geometric sequence. So taking a look at this might be harder to realize what we're multiplying by, but from 1/6 to 1/9 to 2/27, that's going to be 1/3. X to the 8th, x to the 6th, that's x to the -2nd. We're going down 2 exponents. Y to the 3rd, y to the 4th, well, we're multiplying by y. That might be hard to realize, but what you can do is you can take a term and divide by the previous one before it. So 1/9, x to the 6th, y to the 4th, divided by the previous term, which is 1/6, x to the 8th, y to the 3rd. So just put this in your calculator. Do the numbers first. So when you do that, you can just go ahead and put that right in your calculator, and you wind up getting 1/3. Then deal with the exponents. So x to the 6th divided by x to the 8th. Okay, so remember your exponent rules. When we divide with the same base, we subtract the exponents. So that becomes x to the -2nd. Y to the 4th divided by y to the 3rd, that's y. So you probably won't see your answer like this as a multiple choice. It would be, and again, you don't need that 1 there. It would look like this. So the negative x to the -2nd, we'll just move that to the denominator. Question number 6 asks us for a specific term in this sequence. So it asks us for the 15th term. First, let's figure out what type of sequence it is, and it is a geometric sequence. So a geometric sequence, a sub n equals a sub 1 times the common ratio raised to the term number -1. So let's see. We have our first term. We have the 15th. We know n is 15. That's what we're looking for. We don't have our common ratio explicitly stated, but we could figure it out. So in order to figure out the common ratio, 40 divided by the previous term, and that's negative a half. So our common ratio is negative a half. Now we have enough that we need in order to find the 15th term. So the 15th term equals the first term, which is negative 80, times the common ratio, negative a half, raised to the 15 minus 1. So again, we'll go to our calculator to put that in. So negative 80 times negative 1/2 raised to the 15 minus 1, or the 14th power. And we get this decimal. Let's just convert that to a fraction. And as a fraction, that's negative 5 over 1024. So our 15th term is this. So again, we're just using our formula and substituting in what we have. This one again, same type of question. What is the 121st term of the sequence? So if we look at this, this is looking like an arithmetic sequence. It's going up by a constant amount. So that constant amount, that common difference, is a half. 3 to 3.5, 3.5 to 4. So the common difference is a half. Yep, I'm still doing work. Thank you, Miss Kukunis, for ruining that. Okay, lost my train of thought. Okay, so the common difference is a half, and we want to find the 121st term. In this case, n is going to be 121. We're looking for a sub 121. So writing down our formula, we can substitute in what we have. We're looking for the 121st term, but we have the first term, we have the common difference, and we have the term number is 121. So once again, let's go ahead and put that right in. 3 plus a half times 120, and we get 63. So the 121st term is 63. So for this type of question, you really need your formula. I can't imagine you want to test, keep adding a half, 121 times. You'll be there forever. So you really do need to know your formula. So now we're going to move on to recursive formula. And recursive is when we need to have the first term and we're applying a rule, some sort of same process to the previous term before it. So this one asks us to write a recursive sequence and express the next three terms as fractions reduced to lowest terms. So the next three terms would be a sub 2, a sub 3, and a sub 4. We have the first term. They have to give us the first term. And here's the rule to find the terms after that. So let's start with the second term, because we have the first term, so we move on to the second. So we're going to make n 2. So wherever you see an n, substitute it with 2. So n and an n. So the second term is a half times a sub 2 minus 1 to the negative third power. So hopefully you remember in class what a sub n minus 1 means. This really means previous term. So if we kind of analyze this rule here, we're raising the previous term to the negative third power and then multiplying it by a half. So if we simplify this down a little further, we have a half times a sub 1 to the negative third power. But we know what a sub 1 is. A sub 1 is right here. It's 2. So let's just replace a sub 1 with the actual value. It's 2. And then we'll go ahead and evaluate this in our calculator. So 0.5 times 2, or a half, times 2 to the negative third. And we want this as a fraction. So the second term is, I forgot what it was, is 1/16. let's go ahead and move on now to the third term. So we're going to make n 3. So a sub 3 equals a half times a sub 3 minus 1 to the negative third. Remember, now n is 3, so wherever we see an n, 3, replace it with 3. So the third term is a half times a sub 2, or the second term, raised to the negative third. We know what the second term is. We just found it right here. So we can go ahead and replace a sub 2 with what we know it is, 1/16. And again, we'll just go ahead and use our calculator. And this time it winds up being 2048. Okay, so we have the second term, we have the third term. Now it's time to find the fourth term. So I'm running out of room here. Okay. So we'll make n 4 this time. So a sub 4 equals 1/2 times a sub 4 minus 1 raised to the negative third. A sub 4 equals 1/2 times a sub 3 to the negative third. We know what a sub 3 is, just found it before. It is 2048. So we'll just go ahead and replace a sub 3 with 2048. I have a feeling that this number is going to be so small. I just made this question up. I thought it might work out, but we'll see. So to the negative third, and yeah, that number is completely ridiculously small. All right, so don't worry about this. I didn't realize it was going to come out this way, but that's all right. Maybe we'll just change it to find the next two terms, which we just did. Next two terms would be this and this. I think you get the idea. So let's move on to sigma notation. So we want to simplify this. We'll go ahead and do this summation here. 4 plus, and we have a sigma notation here. So now if you remember, this is our starting value, and 3 is our ending value for n. And we're going to want to then add 4 at the very end. So let's maybe just do the sigma notation first, and then we'll add 4 on at the end. So I'll go ahead and do 4 plus, and then this is where I'll put the sigma notation, the summation. So starting with 0. So we'll go ahead and substitute in 0 for n. So that gives us x plus 0, which you probably realize is just x squared, plus, move on to 1, x plus 1 squared, move on to 2, move on to 3, and we're going to stop at 3 because that is our ending value. So we can go ahead and double distribute these. X plus 0 squared, that's a nice easy one. That's just x squared. X plus 1, remember, that's x plus 1 times x plus 1, which is x squared plus 2x plus 1, x plus 2 squared, x plus 2 times x plus 2, so double distribute that if you have to, and that's x squared plus 4x plus 4, and finally x plus 3 squared is x squared plus 6x plus 9. And now we want to go ahead and just add like terms. So x squared, x squared, x squared, x squared is 4x squared. 2x, 4x, 6x, that is 12x. And then 4, 1, 4, 9, what is that, 18? Right, 8, 9, yeah, 18. So this is what it would be simplified, so without the sigma notation. Next one here asks us to express this sum as a sigma notation. So this here, we need to realize what 3, 11, 19, 27, 147, what type of sequence that is. So if we look at this, it looks like we're going up by 8 every time. So that is an arithmetic sequence. Okay, so that's good to know. When we're writing our sigma notation, for all purposes, start at 1, which is the easiest value to start at. We need to figure out what our rule is, and we need to figure out what our ending number is. Okay. So let's figure out our rule first. Since this is an arithmetic sequence, let's figure out just the general explicit rule to find the nth term. So a sub n equals first term plus common difference times n minus 1. So our first term is 3, our common difference is 8, and times n minus 1. So we'll just distribute that out. And we get 8n minus 5. This will now go right here. 8n minus 5. That's our rule. And we need to now find out what term number 147 is, because that is going to be the last term that we add. So to do that, we say, okay, well, what term number is 147 given this rule? So we can add 5 to both sides. 152 equals 8n. Divide both sides by 8. And we get 19. So n is 19. That means 147 is the very last term. So we're just going up to 19. And we can do a quick check. If we substitute in 1, we should get 3. When we substitute in 2, we should get 11. And we do. And when we substitute in 19 the last term, we should get 147. So this would be our summation notation. The last topic was arithmetic and geometric series. So we want to find the sum of the first 50 terms of this sequence here. So first, let's determine what type of sequence it is. Okay, we take a look at it. Looks like we're going up by 3 every time. So if we're going up by 3, that is an arithmetic sequence. So therefore, we want to find the sum, and this would be an arithmetic series. So you will get this formula on your reference sheet, therefore you'll get it on your test. So the formula to find the sum of an arithmetic series would be the sum of a certain number of terms equals n times a sub 1 plus a sub n divided by 2. So first term, your last term, times the term numbers divided by 2. So let's see what we have. We have our first term, that's negative 8. We have n, we want to find the sum of the first 50 terms, but what we don't have is the 50th term. We don't know what the 50th term is. We need that. So what we'll have to do is use our arithmetic sequence formula to find a certain term number. So a sub n equals a sub 1 plus d times n minus 1. So we're looking for the 50th term. So we need to know what this 50th term is. But we have the first term. The common difference we have is 3. And we have the number of terms, 50. So 50 minus 1. Go ahead, use our calculator. Negative 8 plus 3 times 49. And that is 139. So our last term, our 50th term, is 139. Now we're good to go. We have everything. We have the first term, the term number of terms, and we have the last term, which is 139. We can go ahead now and just substitute this right in. So the sum of the first 50 terms is 50 times negative 8 plus 139 divided by 2. divided by 2. So we get 3,275. Okay. So here's another type of question. Determine the sum of the first terms in the sequence here. So again, let's identify what type of sequence it is. Okay, it's an arithmetic sequence. We're going up by 2. Okay, so let's see using, again, you'll have this formula. So first term plus the last term divided by 2. Let's see what we have. Let's see what we need. Once again, we have our first term is negative 20. Do we know how many terms there are? Well, we know the last term is 48, but we don't know what term number this is. So that's a question mark right now. So once again, to find it, we'll have to use our arithmetic sequence formula. So we want to figure out what term number 48 is. Okay, so the common difference was 2 times n minus 1. Go ahead and distribute this out. Okay, 60, so 70 equals 2n. So n equals 35. That means that this here is the 35th term. So now we know that n is 35. There's 35 terms in this sequence. So now we could find the sum of the first 35 terms. So at this point, we'll just go ahead and substitute right in. So the sum of the first 35 terms would be 35 times the first term plus the 35th term divided by 2. Okay, and that's 490. And the last question asks us to find the sum of the first 12 terms of this series below. So this would be a geometric series. And if we want to find the common ratio, if you can't tell that it's 3 by looking at it, we could always do 1/9 divided by 1/27. That does come out to be 3. So the sum for a geometric series, again, you'll get the formula on the test. You'll have it on a reference sheet. It is the sum of a certain number of terms would be a sub 1 times 1 minus the common ratio raised to the nth power divided by 1 minus r. So let's see what we have. We need the total number of terms, and they tell us it's 12. So the sum of the 12 terms of this sequence would be the first term, which is 1/27th, times 1 minus our common ratio, which is 3, raised to the 12th power, divided by 1 minus 3. We can go ahead and put this in our calculator. Okay. And then divided by 1 minus. So I know the fraction's a little weird, but remember we're adding 1/27, 1/9, 1/3, so we are adding fractions. So our sum should be a fractional answer. Okay. And that's it. So hopefully this helped. Again, this isn't all the questions you could possibly see, but it's a great review.